14 and 22. We can add other ones if you guys have them. We should talk about. Oh, you don't want 14 anymore? Does anyone else still want 14? Yeah. Other questions? Yeah. Sorry, guys. 13? 15? 19? Okay. Yep. 18, yes. Okay. So we'll start with number 13. So tangent of 120 degrees. So when I do this, again, you should be doing this without a calculator. So this would probably be like a no calculator portion of a test. So tangent of 120 degrees. So I go past 90 degrees, and if this is 90, I'm going to go 30 past 90. And I'm going to draw my triangle. Again, my triangle always gets drawn back to the x-axis. So if I went 30 past 90, I'm 60 short of 180. So this is a 60-degree angle there. So this is a 30, 60, 90 triangle. And now I just have to label everything the same way I label every 30, 60, 90. However, we have to watch out for the positives and negatives. So I'm going left, and this is going to be 1 because that's across from the 30. It's the shortest side. Going up, it's a positive square root of 3. And then the hypotenuse is just going to be 2. So if I want tangent, I want opposite over adjacent of the 120, which is technically of the 60. So this just ends up being a negative square root of 3. Now your calculator would tell you that as well, but we kind of want to know the why behind it, or like that we can do that without using a calculator. So cosine of 210 for number 14. So again, we have to go past 90, but this time we even go past 180. Now, 180 minus 210 is 30 degrees. So this is a 30, 60, 90, but 30 is our reference angle. So again, I'm going to label it just like I typically would. So across from the 30 is a 1, but since I went down, it's negative 1. The longest, or the side across from the 60 is going to be a negative square root of 3 because I went left. And the hypotenuse is just always positive. So cosine is adjacent over hypotenuse. So from this 30 degrees, negative square root of 3, and then over 2. And that's simplified because it doesn't have a radical in the denominator. Now tangent of 90, any of the 90, 180, 270, 360, all of those are those quadrantal angles, so they're right on the axis. So these ones are a little bit trickier, and they're really easy to get mixed up. So 90 degrees is up here. This coordinate point, we don't go left or right at all, we just go up 1. So this would be 0, 1. Now we learned yesterday that tangent is sine over cosine, or y over x. So you're going to put the 1 over 0. We hadn't really talked about this, but what is 1 over 0? What do we say about that? We say that's undefined. So tangent of 90 degrees isn't defined. This doesn't make, like, there's not an answer for it. So 1 divided by 0 is just undefined. We didn't do an example like that, but definitely worth mentioning. So that's 8. Oh, good. Will you put
Question like that, like on our test.
yeah, that's doable, yeah. Anytime you're dividing by 0, it's undefined. When 0 is on the top, that's when it's just 0. So number 19, and then 22. negative 90. So again, we're on the axis. Now this time I'm just going down 1, so this is 0, negative 1. But it goes cosine, comma, sine. So the coordinate point gives you the answer, so it would just be 0 in this case. And then cosine of 390. And we're going to be talking about angles like this today that kind of is spun around. I mean, we talked about it a little bit last time. But 390, if I go around 360, I'm already at 360. So how much more do I have to go? 30 more. So technically, this is the same thing as the cosine of 30. We call this a coterminal angle. They actually end at the same exact spot. So 390 is the angle you could do. Like think about like if someone's like any of this, like a sport where you like have to turn around, like they talk about doing a 360. So that's the same thing, but we're going a little bit further. So again, labeling things. This is a positive 1. This is the square root of 3. This is 2. Adjacent over hypotenuse. Okay? Alright, so I'll get you guys our notes for today.
I'd be like cats and the paper. Yeah, I just did that. You did that. I did. I just did that. I also did this too. What is this controller doing this on you?
I think it used to be for the I don't think the batteries work.
Actually, that
Oh, what are you doing?
Press cancel.
Cancel.
Are you sure?
I didn't think the batteries were working.
Oh, how much power?
I can take them out and take them.
No, stealing the batteries.
Don't steal that. Aww. I need them though.
Give me a stamp. I got you.
Thank you.
There we go. Oh, he's upside down. But
Come on.
okay.
I got no more left.
Yes. No. Yeah, do not use a calculator for the warm up, please.
Yeah, switch them.
Almost.
Alright.
Yep. Oh well. I'm just like.
You're going to be really excited to find out that our class is now sponsored by Smart Notebook. Every page they're going to put an ad on for us.
It's kind of annoying.
It's a little annoying. I was afraid it was going to print on your sheet, so I was really glad it didn't print. But it was like that we had a trial subscription of it, and like now that we're out, like now there's always going to be that on my screen, which is really, really annoying.
I like it.
So I'm just going with the idea that I'm sponsored by Smart Notebook, and so this lesson is brought to you by Smart Notebook.
Did they pay you?
Why
did the school just pay for a subscription?
Because I guess it's not cheap. I don't know. I didn't
Sounds
ask.
like $5 million.
John, how much money do you think we get? Our school isn't that.
They said if I want Smart Notebook, we have to fire Mr. Donahue. And I was like,
John, I don't choose to try.
Let's go.
more than my relationship. Inspire my children. All right. So yes, please find the exact value without a calculator for these. For John being a wise guy.
Yeah, John.
He was just clarifying. It just said John. Right.
John.
Yeah. That's
John.
You're right.
Yeah. Matthew was there.
Okay.
Sir Thomas.
You're done. You're done. You're done. Hey, you're done. You're done. You're fired.
Okay. I'll get these drawn. I think it is easier to draw them and like kind of visualize what's going on here.
I think you're right.
So when I draw my triangles, I do try to draw them sort of looking similar to what I think they should look like. So like a 30-degree angle, I try to make it look like a 30-degree angle. That way it visually like makes sense to me. Obviously, guys, can you stop please? Like 45 is probably a little bit tougher. My 45 and 60 probably end up looking a lot alike. But so in my sine of 270 degrees, my coordinate point is down here. Guys, make sure you're focused on here, so you shouldn't be other stuff out right now. So sine of 270, I didn't go left or right at all, I just went down 1. And remember that coordinate point, it goes cosine comma sine. If it's helpful to think about it alphabetically, that cosine comes first, even though we usually list sine first. In terms of a coordinate point, this is cosine sine, so sine is just -1. And those of you guys who've seen sine and cosine stuff before, that's all cyclical. So like -1, +1, we kind of like go between those values. We'll talk about that later in this year though. Now cosine of 135, what's my reference angle? A 45. So this is our 45 90 because it's 45 short of 180 or 45 past 90 degrees. So I'm going to label everything using my 45, 45, 90. So 1, 1, square root of 2. However, since I went left, should be negative. And cosine is asking me for the adjacent over the hypotenuse.
I got you, bro.
But I can't just leave it that way because of the square root in the denominator. And the more practice you do with this, you're going to get better at it and get better at simplifying those radicals. All right, tangent of 210, this is the 30-degree reference angle because it's 30 past 180. So this one goes down, it's -1. This one goes left, so that's a negative square root of 3. 2. And tangent is opposite over adjacent. I'm going to multiply each of those by the square root of 3. And the negatives cancel, so it's just square root of 3 over 3. It ends up being
I was
positive.
gonna say I didn't see the negatives with the square root.
What's that?
I was gonna say when you multiply, I didn't see the other negative.
Oh, yeah.
So
Yeah.
okay, I got it right anyways.
Okay.
Let's go. It's a little laggy up there. It looks like.
Yeah. All right. So what we're talking about today is going to be a lot of the similar things that we talked about yesterday.